Welcome to part 2 of a video series created for students studying safety analysis of a quadcopter. In this video, you will learn how to import geometry and add local and global sizing for a surface mesh creation. You will also learn how to add boundary layers and complete your mesh with a volume mesh. You can launch Fluent Meshing in two ways. You can start from space claim, which we covered in the previous part of the video series, or you can launch Fluent Meshing in a standalone mode. To launch Fluent Meshing in a standalone mode, similar to space claim, you can go to the start in Windows machines and search for Fluent and then launch in Fluent Meshing mode. The Fluent Meshing Launcher allows you to apply some settings before applying the meshing setup. One of the settings is capability level. That depends on the license availability through your companies or your work groups. The other setting is solver options. You can go for double precision if you have a multi-phase or a simulation with high gradients. You can also define the parallel setting. This is your Fluent Meshing interface. These are the tasks you have to complete for the meshing. Fluent Meshing will guide you through the workflow, and if necessary, you can add extra tasks through the advanced options for the high level of control on your meshing. The first step would be to import the geometry. You can control your surface mesh by adding some local sizing. We can try some local sizing for the propellers. So you can say yes. Then try to find the rotor walls. You can select multiple items. Then define the target mesh size as 2. Then add local sizing. The next step would be defining some global sizing. Global sizing will cover the entire geometry for the mesh creation. For the global sizing, we need to define minimum and maximum sizes. Please remember that the maximum face size should be approximately 10% of the cross-sectional spacing for the internal flows. And the minimum size should be small enough to allow resolution of the small features. We can try the minimum size of 2 mm and then the maximum size of 40. The default settings for the curvature normal angle should be okay for this study. In general, the finer curvature normal angle creates finer surface mesh. The next setting is the number of cells per gap. The default is 1, but when you have a narrow region, it is recommended to go for 3. The scope of proximity can be changed into faces and edges. Now you can generate the surface mesh by pressing this button. After surface mesh creation, the maximum skewness is reported in the console. We have a good maximum skewness here. But if the skewness is not right, then you can just go to generate the surface mesh, right-click, and then add extra task to improve the surface mesh. Now we have to describe the geometry. For this study, we haven't included solid bodies, and we have only fluid regions, and for the solid bodies, it's going to be some void regions. So describe the geometry as it is. At this stage, update boundaries will be popped up. You can change them here or later inside Fluent Solving mode. Next, you can update regions. In this study, we are going to have 4 fluid regions for the rotor, so change them to fluid. They are going to be defined as rotational zones. And then we have 1 zone for the enclosure. And then for the main body of the drone, we are not including the solid body, so that's going to be defined as a dead zone. Update regions. Next is to define boundary layers. For this study, you can just follow the default settings. Add boundary layers. Then go to generate the volume mesh. For this workshop, the polyhedra volume mesh should be okay, and then you can just follow the default settings. Press Generate the Volume Mesh. Depending on your geometry, this mesh creation would take some time. And depending on how fast your computer is, it's going to be different. When the volume mesh is completed, the orthogonal quality will be reported here. Orthogonal quality usually ranges from 1, which is perfect, to 0, which is very poor. And it is desired to get something larger than 0.1. And if the orthogonal quality is not in that range, then you can improve volume mesh using improve volume mesh task. To add the extra task, you can go to generate the volume mesh, right click, insert new tasks, and then go for improve volume mesh. Then improve. The number of cells that you've got is 6.7 million. If you try different minimum and maximum size for the global sizing, you're going to get different cell number. If you're happy with the mesh, you can save your mesh file for future analysis. To save the mesh, you can go to File and Write Mesh. The next step is to switch to the solution mode. Now you are in a solution mode of Fluent, and I will cover the details in the next part.